and Clojure script, a bunch of stuff in the Clojure community. The man needs no introduction. So please give a round of applause for David Nolen.
Hi, good morning. So this talk is called How to Win Big with Old Ideas. This talk is very much a sort of industrial software developers sort of experience report about a couple of programming languages as well as a database. Basically I want to focus on, I'm not going to show that much code, I'm not going to talk too much about sort of the detailed concepts behind any of these technologies. I just sort of want to give an overview on how you could take, I would say, sort of off the beaten track ideas and have some success in the mainstream with those ideas. So I'm going to focus on Clojure, which is basically a 9-year-old project now. It's a dynamic functional Lisp that targets the Java virtual machine, as well as Clojure script, which is simply Clojure that compiles to JavaScript, and a little bit about Datomic, which is an immutable relational database, which uses data log as its query language. As far as the mainstream is concerned, these are not, accepted technologies. Yet somehow, over the past almost decade, we've been able to grow a large community of dedicated industrial software developers who really love this stuff. And so we're going to sort of drill into why I think that happened. This is mostly, there's not going to be any hard evidence. This is mostly a fun talk, and just my experience watching how things have happened over the years. So quickly about myself, I'm a software engineer at Cognitect. I work on the Datomic team, on the Datomic database, which is the one product that the company has. The company is primarily a software consultancy. So I also am the lead developer of Clojure script, again, which is basically Clojure that compiles to JavaScript. As far as what do we do, we work with companies that have existing code bases written around Clojure, Clojure script, and Datomic. So it's not like we're just coming up to people and saying, we're going to build this thing for you. People have already built stuff using this technology. I believe, we have lots of different types of clients, but 14 of our clients are Fortune 50 companies. So somehow we convinced very big companies to use a very crusty technology as far as technology is concerned. Data log is old, Lisp is old. So how did this come to be? We're going to drill into that. So even if you go back 10 years, I think the future of Lisp looked pretty dire. If some of you are fans of Lisp, I mean, it was definitely in decline. I think if you were sort of a programming languages geek or researcher, I think it should have been a bit of a wake-up call when MIT switched away from Scheme to Python for their introductory computer science course. This was basically, I think, kind of like an indication that things had changed very dramatically in the industry. What industrial software developers wanted was not just a programming language, right? Their expectation was that in this new open source culture, I should be able to build the systems that I want to build without wasting a whole lot of time building infrastructure libs, which was not the case. Like, back in the early 60s, 70s, or 80s, people built everything from scratch. But if you're a web startup, you don't want to become an expert in writing low latency asynchronous web servers, right? That's not going to happen. You just want to use Netty or Jetty. If you're into machine learning, you're not going to sit down and write a distributed machine learning framework. You just want to use Google's TensorFlow, right? So this is only going to continue. People do not have time to build these sort of critical libraries. They just want to solve the problem that they want to solve. And again, I think this is a trend towards industrial software developers want to build systems now that are orders of magnitude more complex than they wanted to in the past. So this is not a great story for people who are interested in programming languages, because it's so much work to even get your programming language off the ground. This is just a slide I cribbed from Simon Peyton-Jones' talk on Haskell that he gave at OSCON in 2007. And this diagram is, I think, far more grim than just successful research languages. I mean, I think this applies to almost all programming languages today. So in some sense, the question is, how did Clojure avoid this sort of kind of language geek ghetto and slow death that most programming languages experience? So at the top of the programming language food chain these days are two languages I don't think are going to go anywhere, at least in the next decade, probably more. and you can pick a few languages. Really the top 10 hasn't changed dramatically, but definitely two that you could like throw a rock and hit somebody and like, what do you do? There's a good chance they're going to do Java or they're going to do JavaScript, and this is not going to change. Um, and these technologies are entrenched, regardless of what do you think about the semantics of these languages. They have their problems, and I think they're pretty well known since almost everybody has had to work with one of these. Um, but the fact of the matter is that the amount of sort of investment that's gone into making these things palatable to the industrial software developer is pretty intense. If you've ever fired open IntelliJ, I mean, the amount of semantic information you have about a Java program is pretty mind-blowing. I can download any random Java project, know absolutely nothing about its build system, and hit run and build it because the tooling is just so good. They can identify any build system that it used and build the project for you. If I open up a test file, even though I don't know what test framework it uses, I can select a method and run that test. So the amount of tooling is incredible. If you are an industrial sort of Java developer, the kinds of profiling tools that are now available for examining production systems is pretty wild. Java has this thing called a Java mission control, which is you can hook it into a live production system, and it's very low latency. I think it's like I don't know, 1% hit on performance, and you can see the memory profile when the garbage collections happen and all this and so forth. So this is the type of thing that an industrial developer wants. They may not love Java, but this is the kind of tooling that they're excited about. The same is effectively true now for JavaScript. So I actually spent a lot of time doing JavaScript at one point, doing UI work for various clients. For a while, I was at the New York Times for 4 years doing UI stuff. But I started doing JavaScript stuff in like 2005 when you still had to basically support IE6. And the state of the art there at the time was print line debugging, right? Because you just didn't know what would happen. You might have made a bug, and then IE6 would just crash. And really the best debugging methods you had was just alert debugging, not even print line, because there wasn't even a console. But things have dramatically changed. From a tooling perspective, the things that are built right into this average browser, Chrome, Safari, and Firefox, it's very sophisticated, very advanced tooling. If you're a UI developer, the sort of insight you can get into how much time is being spent in repainting and layout and JavaScript execution. What does the heap profile look like right now? All this stuff works extremely, extremely well. So again, these are now that developers have this, the likelihood they're going to put up with a language that doesn't, it's diminishing. JavaScript also, probably more so than Java, has a lot of room to grow, specifically because you have this now sort of fragmentation of the sort of platform market, just because of the stiff sort of competition that happened in the sort of mobile space. But what this means is that companies don't really want to hire 3 different teams to build the same app, and that this has created a lot of pressure to make JavaScript the sort of future of UI development, because at least with JavaScript, you can easily target multiple platforms. So I expect JavaScript to really actually increase in scope and as far as where people want to use it and how people want to use it. So given this, Clojure's strategy was that we can't win by building our own system, by building our own island, by building our own environment. The environment, sort of the mainstream has sort of dictated what we have to use, and so Clojure's strategy is we're simply going to have a symbiotic relationship. This I think is something that's not really thought, sort of realized that was a very smart design trade-off for Clojure, in that we're just going to go with the flow, right? Wherever the industry is going to go, we're going to follow them. So Clojure is very much a symbiotic programming language. ClojureScript is as well. So ClojureScript simply targets ECMAScript 262 JavaScript. It compiles to the same JavaScript that shipped in 2001. So this guarantees that we can run in basically any JavaScript environment, like even in Rhino. Okay, so I think part of the reason Clojure has done okay for a language that, again, that is somewhat esoteric, is that we've simply adopted a symbiotic sort of stance with respect to mainstream technology. The other thing, which is what I'm going to drill into, because I think if you think about it a bit, the symbiotic thing sort of makes sense. Developers want to target these popular platforms. But there's another thing I think why people sort of have fallen in love over time with Clojure is that Clojure actually, at its core, has, I think, a set of very simple principles that actually came from academia. And they're almost inevitably all old. I'm only going to talk about 4. If you're a Clojure developer, you could pick any 4 that you want. I'm picking the 4 that I think are interesting and I think that have a huge impact. And in fact, I'll show some demos of sort of initiatives by the community that specifically leverage the things I'm talking about. But again, I think what makes Clojure nice is it's a very well-curated set of old ideas that we know work pretty well. And I think when developers come to Clojure, they don't have to spend that much time with it to realize the sort of software engineering benefits of these things. The features I'm going to talk about are not complicated. Again, they're almost self-evident. The other thing that I like about these features that I'm going to talk about is that they're really simple. So probably these days people actually know what I'm showing here. If I'd shown this in the Western world even a year ago, you'd be like, what the hell is that? This is a Go board, which is now easy to recognize because of Google DeepMind's AlphaGo competition. But the neat thing is, regardless of whether you know how to play this game or not, is that for about 2,000 years, people only communicated the rules just by describing them, because it only took about 10 minutes. There was no need to write them down, right? And this is really important. I mean, I think there's lots of software features you can talk about that require you to read papers or require you to invest a lot of time and energy. But the features that I'm going to talk about really are not like that. You really could describe them to somebody, and somebody could probably implement it themselves in an afternoon. And I think that's really important. So what's neat about Go is that even though these rules can be communicated in about 10 minutes, the game has sort of somehow stuck around. This is a game record. It's 1,200 years old, but it would be trivial for a person to read and understand today. And just because an idea is simple, right, that only takes 10 minutes to explain, it actually says nothing about the power or the depth or the complexity of the resulting system, right? Go has very simple rules, but Google had to spend about 10 years of new AI research. They had to build custom silicon, and they had to build a supercomputer, and they still lost one game to a human. Okay, so what are some of these old ideas? So 4 old ideas. One is Lisp. This is a programming languages conference, sort of has a programming languages bent, so everybody's going to know what Lisp is, but I'm going to point out a thing which I think is, even if you know Lisp, specifically something that people love and that people really run with, industrial software developers run with respect to Lisp. I'm going to talk a bit about trees. So trees are a very old idea. 1960, Ed Fredkin wrote about them. So Clojure sort of changes this is a sort of divergence from the Lisp past of con cells. This core data structure in Clojure is based on trees. And then you have data log, and data log via sort of Datomic, but Datomic has had a huge effect on the community in that people are building their own data log systems, are interested in this approach to data modeling. And then regular expressions, and this is a relatively new thing based off of, again, an old paper in 1964, but it was revisited by Matt Might in 2011, and then Rich Hickey implemented a thing called Clojure spec, which is a contract-like system which uses parsing with derivatives to get validation. Okay, so let's kick it off. So Lisp. They're not going to spend too much time on Lisp because I think people know it. But the cool thing about Lisp, as Alan Kay says, is that it's really simple, right? He refers to the Lisp 1.5 users manual, the one-page thing with eval and apply, and that's really it. John McCarthy created Lisp because he had a goal, right? So a lot of this talk is not about these features, but the fact they enable software developers to achieve their actual goal. A programming language just is some path to something that something actually wants to do. He was, basically tired of this process where you would punch your cards, you would give them to the person who would actually, run that and enter that computer, and then you would get the results maybe 3 weeks later, and there was a bug, and then you would start this process over again. And I think one of McCarthy's most important innovations was the REPL, right? He was like, this is ridiculous. I should be able to sit at a terminal, type the thing I want to type, and see a result right now, not 3 weeks from now. And this idea, fortunately, has had a lot of traction. I think it's very hard, finally, in 2016, to see new language efforts that don't have REPLs, which is great. So what are the benefits of the Lisp approach to software development? Again, even though Lisp sort of came from as a sort of academic research, what are the practical benefits for an industrial software developer? From a maintainer's point of view, it's actually quite nice, right? Lisp is one of these things that still to this day, it's fairly simple to implement. I mean, wait, so raise your hand if you've ever implemented a Lisp interpreter. So that's ridiculous, right? That's a lot of people. So it's not a hard thing to do. And once you do it, you almost can do it in your sleep, right? This has the flavor of the rules of Go. Somebody shows you how to write a Lisp, boom, you're never going to forget how to do it. And that's really cool. But it's great in terms and from the point of maintenance, as people who have to maintain this project, in that the language is quite small, the implementation is quite simple, and that's great. And we're 9 years in, and we don't have an elaborate contribution process or anything like that. I think only 3 people have commit rights to Clojure still to this day. The other benefit is that we adopt, macros appeared fairly early in Lisp history because people realized, oh, the language is very uniform. We can do metaprogramming through macros. And so this has also been nice in that, one thing that you see a lot of programming languages do is once you pick a language which does not have an extensible syntax, then you really actually have to have a sort of more committee-oriented system, or some system in which that people say, here's my idea how to improve the language, and you have to, like, make a little request for enhancement and yada and so forth. So macros don't let you do everything that you want, but a lot of basic extensions that people might want to need for their domain, it's available, right? They don't need to talk to the core team to get the feature that they want. Many features can be implemented through macros, and that's a really nice thing. Something that's finally paying dividends is taking a bit longer because it is a bit more complicated than just writing a macro, is that the simple implementation actually means that the community is able to retarget to other desirable platforms. So we've focused on Java and JavaScript, but because the compilers are really actually quite simple, I'm going to talk about some other things. It's not work that we did, that other people were able to retarget, which is quite cool. Does not require a lot of effort. A lot of the things I'm going to show, it's like people have enough time to do this in their free time. And definitely porting Clojure libraries, it requires often a trivial amount of effort. Okay, so that's Lisp. So another sort of powerful, simple idea is trees. Again, Lisp sort of started with an emphasis on the sort of cons cell as like its sort of foundation. And the thing is actually the idea that Clojure adopts is very close, right? Like the tree implementation that we have are very close to Lisp. Right? All you got to do is say, well, we can't set the car and we can't set the coder, so no mutation of the car and the coder of the cons cell. And then instead of having only 2 branches, we're going to make it so, or actually only one pointer, we're going to actually have 32-way branching, and we're going to use mutable arrays as the fundamental sort of unit inside the thing. But everything that we like about persistent data structures is already present here. Structural sharing is already here. The only thing that's missing, so you're going to get efficiency in terms of space, but we want efficiency in terms of time. And so if you're a bit careful with the branching factor and you use 32-bit arithmetic, you can actually do some neat tricks. So again, this is an old idea like Lisp. Lisp was 57, trees were 1960. So you take trees, you read Okasaki's book on sort of functional data structures and path copying and updating, and then you might have stumbled across a paper by Phil Bagwell, who wrote this thing called Ideal Hash Trees, and he sort of defined what a hash array mapped tree looks like. And this was actually a mutable data structure. And so what Richiki did, he said, okay, that's a very efficient hash map implementation, and the way that it works, I can just change this and combine Okasaki's idea and get an efficient set of immutable data structures. So we don't use cons cells as the fundamental unit of our data structures. We use various forms of hash array mapped trees. And what are the benefits? What are the benefits for your average software developer to build your whole language on this? So the mutability is at low prices, right? I think right now, even with the branching factor of 32, I think if you actually have the full depth of the tree, if you have an immutable vector and you actually had the maximum size, it would take about 256 gigabytes of RAM, which I don't yet have on my computer. One day we'll get there. But the point is, even if it's that big, and you have, I think, 2 billion items, it only takes 7 array accesses to get to any particular element. And because of things like the fact that JVM tries to be very sort of inline cache friendly with small arrays, this ends up being much cheaper than people expect. And this actually ports to JavaScript. So a lot of these tricks that people have been doing inside the Java virtual machine are making their way into JavaScript virtual machines. They're extremely advanced now. Lock-free concurrent programming for the masses. So, a lot of people don't talk about this, but the average Clojure developer is using the JVM, they're writing multi-threaded programs, and they're doing this without locks, and nothing bad is going to happen. And that's really cool. But even if you take immutable data structures and you put them in a single-threaded context, this is less obvious, and this is sort of a recent development from about 2 years ago, there's still benefits. And this boils down to how good it is for UI programming. So ClojureScript developers design entire applications around immutable data structures. They don't use mutation as a fundamental sort of thing. And very cool, and I don't think we've really completely mined the possibilities there. But I've done demos of like, okay, so undo and redo and complicated sort of change trees. All this stuff is sort of it's self-evident because it just works. You can combine immutable data structures with a sort of functional rendering pipeline like React, and things that used to be quite challenging are very trivial. Okay, so data log. So data log, this is again old idea. I couldn't find, maybe somebody here is a data log expert and they can point out a year, but data log is sort of lumped in with sort of Prolog. So if you remove the sort of non-termination aspect of Prolog, you end up with something called data log. So in 2012, the Cognitech team announced this thing called Datomic, which is a mutable relational database. It's, you could say in a very, very short sentence, it kind of works like Git in that you have immutable blobs. But basically it gives you a relational querying system over something that's kind of like styled after, like I would say, an RDF store in that you sort of have queries over tuples. It's a mutable relational database. It has a data log style query language. And the tuples are effectively entity, attribute, value, and time. And the time thing is huge. So because it's an immutable database, one of the biggest problems in software systems is like, okay, you use a functional programming language. The semantics of your language are great, except at the edge of your system, you have some mutable thing, which really destroys all the semantics. The most important operations, saving information and reading information. There's no guarantees about that stuff. But Datomic basically gives you a database which actually feels like it's just a data structure in your program. You don't even think of it as a database, and it has the same nice immutable properties, and that's quite cool. And so because it has this element of time, it's easy for users to write very simple queries. You don't have to like think about again, because it's sort of oriented as queries over tuples. You don't think about joins. You can add schemas whenever you want, new attributes, so on and so forth. So it's both flexible in the way that industrial software developers want, and at the same time, you don't lose querying as you would with, like, say, a document store. So here I'm saying I want to find the timestamp. I have a clause. We're saying find, the tuple that matches this sort of pattern, right? Find the entity P such that that person's name is James Cameron, and then find the logical transaction ID, the logical transaction time. And given that logical transaction time, give me the actual instant that piece of information, that fact was recorded into the database. And this is also similarly, right? You sit down a developer and like they can learn this query language in an hour, and people really love it again because it's sort of self-evident. Sort of serendipitously, it turned out that things were already heading this way for the rest of the industry. So I don't know if people are familiar with React, but React was Facebook's sort of functional-ish rendering pipeline, even though it has a sort of object-oriented veneer. In essence, it's a functional rendering system. And they announced something that they'd internally been using for years called GraphQL. Because Facebook is essentially, that's all it is, a social network, and the only thing that they want to query are what are the relationships. Well, they have a whole graph-oriented query language. And it has lots of benefits because Facebook, along with Netflix, these big companies are realizing a lot of our queries, we really want clients to be able to describe what they want. Because, for example, Netflix has to write queries, right? Clients need to be able to, like, the clients could be, okay, maybe it's a set-top box, maybe it's a web browser, maybe it's Android, maybe it's a tablet. These all have different views. They all render different content based on the dimensions of the display. And what was happening is that, okay, you have a low-bandwidth client that's a watch or something, and it still has to download a 1 megabyte JSON payload when it only needs 2 fields because that's all it can display, right? And so this is a problem that people are seeing as clients diversify. The old sort of REST style, I'll just send whatever we're going to send to the client, it stops working, right? Because different clients need different things. And so, I've done a bunch of talks about this sort of demand-driven sort of uh, thing. So people are getting more and more interested in graph databases and graph database-like systems, right? People have been, for years have been saying, we need graph databases, and industrial software developers are like, why the hell do we need that? And now, finally, things are happening that they can see the value of that. Okay, so flexible modeling without abandoning relational queries. That's what's nice about Datomic and taking this data log style approach. Again, delivering sort of immutability, which gives you powerful auditing. And it turns out that people like this idea so much that they've actually said, oh, I would love to have that on my client. I would like to download some data from the server, and then I want to be able to write nice little data log queries in the client to express different states of my application. So people are starting to see the value of this for the typical applications they want to write. And again, this is sort of, we got a bit lucky here, and people are excited about this, and that it's just a good fit for the types of applications that are in vogue. Many applications these days have some sort of social networking component, and many companies want to target extremely diverse clients. Okay, so the last thing that I want to talk about is regular expressions. So this is yet another, based off of yet another old paper. This is from '64, derivatives of regular expressions. So this idea sort of is the underpinning of this new sort of contract-like system for Clojure called Clojure spec. It's a neat paper, and Matt might revisit it, and people got excited about it. It definitely in the academic world. But Clojure sort of uses this in a very kind of fun way. When people hear regular expression, they're like, well, aren't you talking about strings, but actually regular expression in the sort of mathematical sense, which is definitely, I would say, is not something industrial software developers are familiar with, but I would say computer science researchers probably are. And what this paper does is it shows in 30 lines of racket, you can basically get the full power of a context-free grammar, right? It's really neat. You only need 30 lines of code, something that anybody could understand, whether an academic or an industrial software developer. So this is the underpinning of Clojure spec. Instead of operating over strings, we're going to parse S expressions. So Clojure is sort of an extended form of S expressions, right? So we don't just have lists, we also have, hash map literals and array-like literal things. And so it looks a bit like this. People can talk about properties in their programs, like properties in hash maps, or they can talk about functions. They're able to say, I want, because you can think of the arguments to a function as like a tuple, you can say the arguments to this function needs to be a tuple. The first thing should be an integer. The second thing should be an integer. And then I want to have this logical predicate that says that first thing should be less than the second thing. So this is quite nice. You have a lot of descriptive power over how your function is supposed to work. But because this is a declarative description, you can do a lot more things, right? So this specification doesn't have to be in the same file as the place where you write your functions. The specification can live anywhere. It's sort of a la carte. The neat thing about it is because the specification is declarative, we can do data generation off of it. So maybe some of you have heard of this thing called quick check. Quick check was a new idea, I think 2000 or something, but originally a thing for Haskell by John Hughes et al. And he took this idea, and now he runs a whole company called Cubic, which uses the Erlang quick check to do sort of deep specification. And they've already used this successfully in a lot of industrial systems to verify bugs, both in hardware as well as software. So what's great is that in order to understand this paper, you actually have to be a little bit familiar with Haskell, and you have to know something about monads. And the nice thing about Clojure spec is users don't have to know anything about that, right? You just write your spec, and behind the scenes, we can generate your data for you. And so that's really powerful, that users don't need to know that much about how this particular thing works. So this is a little bit subtle. So what are the benefits of something like Clojure spec, which uses this neat sort of regular expression approach? Of course, richer documentation. This is the thing that people complain about. I think the #1 reason why people like types is just, what the hell does this thing do with me not having to read the body of the thing? So that's great. People now have a shared language of what this thing receives, what it takes, and what are the constraints upon the relation between those two things. Better feedback. Because it's a parsing technique, it's actually, in the implementation, it's sort of, we have a simple way to propagate precisely where your program went wrong. Like what specifically in your data was not correct. And that's huge, because a lot of what people want is just better feedback. Many programmers, industrial programmers, don't care. Did the error happen at runtime, or do I know about it at compile time? All you care about is how informative the error actually is. Um, it also eliminates handwritten macro body parsing code, because now that we have a way to talk about the structure of a Clojure S expression, I don't have to write parsers. I don't have to write functional code to parse a macro body, and that's quite nice. And again, property-based testing for free, and something that it's a bit too new to see what people are going to do with this yet, but the fact that you have a la carte specifications, right? So these days, when you're writing a program, chances are you're writing two programs, one on the client, one on the server, right? Wouldn't it be nice to have a specification that you can share across these two endpoints? Okay, so this is my sort of idiosyncratic take on some interesting features that are based on, again, I would say, well-known, well understood, and good academic ideas. So what does this add up to? What do people do with this stuff, right? So what I'm going to show are some demos of things. This is not anything that the core team works on. This is purely industrial software innovation. Somebody takes, okay, I get it, Lisp. I can do hot reloading. Oh, functional programming, immutable data structures. What can I do with that, right? So the next demos I'm going to show are just things that people figured out on their own. The first thing I want to show is this thing called Figwheel. So Bruce Hellman, very nice person. This tool, again, we did not design this. We did not develop this. He realized, okay, you have Lisp, and hot loading is a nice thing in Lisp. And then you have immutable data structures. It's already idiomatic for most Clojure programs and ClojureScript programs to put the entire application state inside of one reference type, right? So the entire thing, it's like a database. You put all your state in one place. And because this was already the case, he was like, oh, I can build a hot loading sort of system that simply watches the file system as files change. If something successfully compiles, I can reload that in the browser. So again, we did not design this. This is, oops, do I have to, sorry, this is not open. Oh no. This one? Is it, which, oh, sorry. Let me turn on mirroring. Command F1? Wait. Yeah? There we go. Okay. What's the network here? Chroma? All right. Sorry. Okay. Well, that's easy. Excellent. All right. Is this going to work? Is it going to be really slow?
Flappy Bird has a Flappy Y value, and that's what we want to associate with the sine function. So give it an amplitude of, say, 60. So it'll move up and down 60 pixels and get the sine, and the sine will be of the time delta. Excellent. So there's a naive sine wave. Let's hook it into the update function for the Flappy Bird. There we go.
This is in
Save the file.
web browser.
And Flappy Bird is bouncing up and down at the top. So I forgot to give it Flappy's initial offset, which is a start Y. So let's give it start Y. It's beginning Y position on the page. And then add that. Now Flappy's in the middle, but still bouncing around frenetically. So
anyways, that's so if you've done web browser development, right, a lot of time is lost just blowing away the state of your application. And all you want to do is change how something looked, or you wanted to fix a bug. And so this is, again, this has completely taken the ClojureScript world by storm. So a lot of ClojureScript developers, they just live code as they're developing their UI components. They don't have to stop, blow away their state. They're able to keep their state intact as they develop their program. extremely powerful. And again, not something that not an initiative that we started. It just fell out of the semantics of the thing that we provide. Another thing is that, JavaScript, the cool thing about JavaScript is everywhere. It's just going to go more places. So there are lots of places where Java can't go, right? Java's probably never going to run on Apple's iOS. But something that's cool, we did a very Lispy thing last summer. So the ClojureScript compiler can compile itself into JavaScript. And it didn't take very long for people to sort of run with this. And so this is ClojureScript, which has compiled itself into ClojureScript, running in iOS. And so this is the whole ClojureScript language inside of iOS running under JavaScript core. So Apple has this, their JavaScript engine, which is a standalone embeddable thing. And this is Mike Fikes showing a demo of this at work. Also very cool. Will it work? Maybe.
An effort that is going on to kind of add this stuff to it. So, as you're typing, it basically maintains your parentheses for you. So, and this is actually on my iPhone. It's actually right here running, but I have it on the screen as well. So let me try entering in. I'm going to subtract maybe from 4 the first of a vector where maybe the first element's, I don't know, 6 and some other symbol. And if I put something else in there, it's like really easy to add and delete. And maybe if I move my cursor over here, let's see, maybe put another number there. I don't know. So
what he's demoing here is actually, you don't need a special keyboard for this particular REPL because it uses this really neat, again, community thing, which is a parentheses inference sort of engine. So a user doesn't need to input parentheses correctly. It'll be inferred based on indentation, which is quite nice given the sort of limitations of trying to type on an iPhone. But Mike Fikes actually, he's built all the technologies that any random person can actually write npm natal or something, and they have a fully blown interactive REPL hooked into their iPhone, right? So you can develop iOS applications. You only have to bootstrap once, and you can basically program your iPhone over Wi-Fi. And all this stuff around hot loading, all that stuff just works, which is really cool. And again, we're not working on this. This is just people took the thing that we have, and now they're able to live code their iPhones. The last demo, so this is looking for a little bit further into the future. So I talked about Clojure, which is JVM, ClojureScript, which is JavaScript. This are my friends, Tim Gardner and Ramsey Nasser. And so there is a compiler, which actually people weren't using very much, the Clojure CLR compiler, and they realized that they could target Unity with this. So if you're not familiar with Unity, Unity is probably one of the most successful game frameworks of all time. Multiple, blockbuster titles for mobile devices have been produced on it. I think they have like a 1.2 billion valuation now. It's very successful. Unity is a great authoring tool. That's sort of what allowed it to be to take off. Is that it's great for artists. For programmers, it's not that great. So Ramsey and Tim saw an opportunity here. They saw that Clojure developers have this really nice interactive live development workflow. In our free time, we're going to make this work for Unity. So they have this really amazing demo where one of them has like a VR helmet on, right? They actually have a VR, like an Oculus Rift, and then one of them can be typing on an Emacs buffer, and they're live updating the Unity environment.
I can go over to these pyramids. And they're floating about 10 meters in the air right now. Now they're falling, kind of bouncy material. They're spurring towards us. Sort of jump up on here, maybe. Okay. Now I'm up on a corner of one of the pyramid blocks. Forget what this does. What does this do? Anything changed? Oh, forget that one. Oh, no. Okay, something changed. And then finally, well, I'm going to put the pyramids back because I need a little bit more room for this next one, I think. So, there are the pyramids again. Yep, just going to leave them for a second.
Anyway, super cool, right? So they're you know, professional game developers, and they want the same thing that we have in these other environments, right? So they see the main thing that they want is just again, more feedback, more inactivity while they're developing their software. And in fact, a lot of my points are reflective. So we run surveys every year, and in this list, people say 2,400 responses. People say, what's the most important thing? And you can see the more sophisticated language features are at the bottom of the pile. The first thing is people like is functional programming. The second thing they like is immutability. The third thing they like is the REPL, right? All these demos I'm showing you are just REPL demos. People absolutely love the REPL demos, especially if it works for the platform that they care about, right? iOS, Unity, web browser, Java. And the last is just ease of dev. You know, macros are way down there. Transducers, reducers, multi-methods, protocols, all these sort of esoteric things that, you know, that are cool for computer scientists, then developers don't care. I mean, yes, they're going to eventually use that stuff, but the main thing is, does it let them build software faster and with more ease? So how to win? So I would say the summary of this talk would be, you know, gives industrial software developers something that they actually need. Not what they want, because developers don't necessarily know what they want, but give them something they need in the sense that you're an industrial software developer, and you realize there's this huge pain point. Maybe it's state. Maybe it's a lack of interactivity. Give them sort of a, you know, whole system where they can tap into the thing that they're missing. Integrate seamlessly with technologies the entire industry has already invested in. I think this is a hard thing to swallow, but the fact of the matter is if you really actually want people to change the way they write software, you're going to have to meet them in the middle. You're going to have to meet them on the platforms that they want. And only then are you going to get people to do the sort of innovations that I sort of ended my talk with, right? Those are not things that we have done. If you make a system that actually sort of addresses a pain point, people will fill in all the many gaps that exist. Thank you. That's the end of my talk, and I'll take questions.
So if you have questions, please raise your hand so we can give you a microphone.
So you spoke about the possibility to write contracts in Clojure, essentially.
Yes.
And can you tell us something about how widely they are used? I didn't see it in, I think I didn't see it in one of the features that programmers like. And
that's right, because it's new. So the question was, how many people are using contracts? And actually a lot, but they were using a different library to do it. It was a library called Schema. And so, yes, it was one of the most popular libraries that were there. People were unhappy with it because it was actually written with a sort of more, I would say, traditional types perspective, the way that the contract system worked, whereas Clojure spec is very oriented around validation of S expressions. And you don't really have put on like a types kind of hat when you're using it. But people are switching in droves away from schema to Clojure spec. So yes, it is using a contract system is very popular, but the one I described is a new contract system. Does that answer your question?
can you say some more about what that can express? Examples of what you would be expressing?
So if you want to do if you want to do a recursive data structure, right? So you say you want to validate a binary tree. You can say this is the recursive structure, and you can do that. You have basically the full power of a grammar. So anything you could do with a context-free grammar in terms of validation, you can do with spec.
Yeah, so you mentioned quick check in relation to Clojure spec. Can you talk a bit more about what you've done in that regard? Like, do you actually have tools where you can generate tests and all that already, or what's the state of that?
Yes, so when you write a contract and you say this thing has to take a binary tree, then what happens is that we can use that specification to generate the structure that matches. And that's functionality that already existed in something called test check. We can just convert our internal representation of what the validation needs to be into a corresponding test check generator, right? So if you're familiar with quick check, you need to provide generators, right? The types of things that you're going to feed into your program to test that it withholds upholds the property that you care about. So that's all we do. We just take the specification and we create the corresponding generator. So so for people who aren't familiar with quick check is not actually just randomized testing. So the nice thing about quick check is what it actually does is it does generate random data based on some shape, but what it does is once it finds a failure, because it generated the data using something called a rose tree, it can actually shrink it until it finds a minimal failure. And that's huge for usability with respect to the programmer, because it doesn't mean anything if your data, it's like, I see 1 million things, and which one of these things caused my program to fail? You don't want to see that. You want to see a one-element vector that causes your program to fail.
So you specifically work on Clojure script. What has been the biggest challenge for having code compile consistently or perform or execute consistently on multiple backends?
So fortunately, that's not something we have to. I mean, there's been a few times where this has been a problem because of bad implementations that don't follow the spec. But for the most part, again, because we've been playing it safe, we only target a version of JavaScript that's existed, now for 15 years. So most engines have got that well covered.
So I meant JVM and JavaScript.
So we have two completely different compilers. Maybe that wasn't clear.
Right. So someone writes a library in Clojure, and you want that library to perform both well, or the same in JVM, when compiled to JVM, and the same when compiled to JavaScript.
Right. So that just works, right, unless you want to do interop stuff. So as long as you don't have host interop forms in your program, you can just take that program and it's just going to work as Clojure script.
Right. Cool.
How come you push back against your advanced features that are being used? David, you admitted that advanced features are being used.
Yes.
They were called advanced in 1960.
Yes. This is a part of the theme of my talk.
Right. So macros will be used.
It's definitely the case, but it's just that's not what that appears in the survey as what users care about.
I understand.
Yeah.
I was at Clojure West, I spoke there, and I saw a really cool demo and talk about the 737 MAX. So Clojure is also used in critical software. It's flying on the Boeing. It's just being released right now, brand new aircraft, brand new Clojure software right on there. It's really working everywhere, not just in these Androids and web stuff. It's everywhere.
Hi. In the past, several attempts have been made to add types to Clojure.
Yes.
Do you think now this new contract system will get rid of these attempts, or?
I don't think so. I mean, Ambrose Bonner-Chazran, he's still working on core type, though he worked on that, and the thing is, there are many things that make it challenging. I would say that since Clojure wasn't designed with types in mind, many functions have very strange signatures, and it's not that fun to interact with sometimes. And so I think people have discovered that while they want the power of ahead of time checking, compilation time checking, the sort of cognitive cost of core typed is not that great yet. But I know that Ambrose is now looking at gradual typing as a way to find something as a better fit. And without a doubt, he's been putting Clojure spec through its paces. I'm sure he may have new ideas about how to possibly to sort of bridge these two things. Because I actually think, again, I don't think a contract system and ahead of time checking are at odds at all.
Thank you.
right, thank you.
So just a quick announcement. So we're going to have lunches and coffee breaks in 2 different rooms. So pick the shortest line. Okay, thank you.